All right, thanks for hanging in there. We just figured out that when we plugged in positive 4, we get 0 as an answer. So let's use synthetic division with 4 as our root. Our coefficients are 10, negative 63, 87, and 20. So here we go. We know when we plugged in 4, we got a 0, so we should get a 0 as our remainder. So I do 10, 4 times 10 is 40, negative 23. 4 times 23 is, whoops, 4 times 23 is 92, and that'll be negative, so add those up, you get negative 5. 4 times negative 5 is negative 20, and a little happy 0. Don't forget, instead of plugging these things in one at a time, you could just do synthetic division with all of them if you have a lot of room on your paper, and that will eventually get you the answer. So 4 is one solution. It could be as another, it could have a multiplicity of 2, so it could be a solution again. All right, so we've got 10x squared minus 23x minus 5. So that's I got from here, 10x squared minus 23x minus 5. Now, you could keep going if you wanted to, but because so many of our potential answers are fractions, to solve this, equaling 0, to solve this, I'm just going to go straight to quadratic formula. You know, you've got a tool for solving this, and if it's a square, and that tool is the quadratic formula. So now you should just go straight into that. So unless you really, really love synthetic division. So I'm going to do, here's A, B, and C, negative B plus or minus the square root of b squared, and 23 times 23 is 529, minus 4ac, I have two negatives, so that will be a positive. 10 times 5 is 50, times 4 is 200, all over 2a, which will be 20. So as you can see, I've just gone straight to quadratic formula. So 529 plus 200, square root of that is 27. So these two negatives become positives. So we've got 23 plus or minus 27 over 20. So that's going to be 23 plus 27 is 50. 23 minus 27 is negative 4. And there you get two fractions. So this zeros cancel, so we get 5 over 2 as one of our answers. And negative 4 over 20 reduces to negative a fifth. And look at that, 5 over 2 and negative a fifth. There's 5 over 2. There's negative a fifth on our list of potential answers. So there you go. So let's factor this. If we factored it, it would be f of x is equal to, our first root was 4, so x minus 4, times x minus 5 over 2, times x plus 1 over 5. There you have it. If you wanted to, you could rewrite this factor here as 2x minus 5, and you could rewrite this one as 5x plus 1, because that's how they would factor. But if you wrote it like this, that would be fine. That's how you do synthetic division to solve a complex polynomial. So let's move on to the next page. This one's going to be cool. Find a polynomial with roots of 3, negative 3, and 5. Well, if a polynomial has those three roots, we know how to write it in factored form. F of x is going to equal, the first one is going to be x minus 3. The second one is going to be x plus 3, right? We're just flipping the signs. And the last one would be x minus 5. So there's a polynomial with roots of 3, negative 3, and 5. That's in factored form. Let's go ahead and write it in regular form by foiling. So let's FOIL these first two. It's going to be x squared plus 3x minus 9 times x minus 5. So that cancels with that. So we got x squared minus 9 times x minus 5. So let's FOIL this. X to the third minus 5x squared minus 9x plus 45. So this is the answer. But another way of writing the answer would be f of x equals x to the third minus 5x squared minus 9x plus 45. And that should be an x right there. So if you plug in 3, -3, or 5, if you plug in any of those three numbers into this, you should get a result of 0. So it's a lot easier to go from knowing the roots to the polynomial than it is from going from the polynomial to the roots. Next one. Find a polynomial with a leading coefficient of 1. That's good to know. That means there's going to be no number out here. And roots of, or zeros, means the same thing, of this, this, and this. All right, so there's something really important going on with this one. And that is that, well, first off, let's write down what the polynomial would be. It would be f of x is equal to, now, I need to do 1 minus all of this, okay? So it's going to be 1 minus all of 1 minus root 5. And 1 minus all of 1 plus root 5, okay? Does that make sense? You need to do, I'm sorry, not 1 minus, x minus, my mistake. So just like when we had a root of 3 and I had to do x minus 3, if I have a root of 1 minus root 5, I got to do x minus all of 1 minus root 5. Next, I have a root of 7 minus I. So this is going to be x minus all of 7 minus I. Now, there's something really important here that a lot of students forget. If you have a complex root, remember that I is equal to the square root of -1. If you get a complex root, the conjugate is also going to be a root. And that's kind of another result of the fundamental theorem of algebra. So if 7 minus I is a root, then that means 7 plus I, the conjugate, is automatically a root. And it's kind of a trick question that they told you that 7 minus I is a root, because you should know that automatically its conjugate will also be a root. So we need to do x minus 7 plus I. So there's the polynomial. Okay, there's the polynomial. It is quite intense, and so what we are going to do is we are going to simplify this a little bit. I am going to FOIL it for you so you can see how to do this. But just remember that critical fourth root. You're always going to have an even number of complex answers, and they're going to come in conjugate pairs. Okay? It's actually going to simplify kind of nicely when we FOIL this. So here we go. I have three. Oh, first let's rewrite this really quick. So this is x minus 1 plus root 5 times x minus 1 minus root 5 times x minus 7 plus I times x minus 7 minus I. So I just distributed my signs there very carefully. All right, and I'm going to FOIL this, and I'm going to FOIL it in part 5 for you.